A lot of people asking me about number 2, and so I want to make sure that I post a good video for this one. The graphs below show some data from a coffee shop menu. One of the graphs shows cost in dollars versus drink volume in ounces, and one of the graphs shows calories versus drink volume in ounces. So one of them is cost and one of them is calories. So we have to try and decide which one is which. So it looks like volume in ounces are always on the x-axis, and so we have to, I guess, just use some common sense here. You're not going to be looking at something that has 3.75 calories or 4.95 calories. So this is just using some general knowledge of money and amount that you would get at a coffee shop and calories that you would get in a particular drink. I mean, 360, 150, those look like numbers you would see on a nutritional facts label. So this one has to be the calories one, and this one over here must be the dollars. So that's just using some common sense and looking at, the 375. I mean, that looks like money. 4.95, $3.75. So that makes sense. Which graph is which? Give them the correct titles. Dollars versus volume, calories versus volume. So check for part A. Which quantities appear to be in a proportional relationship? And explain how we know. Well, to do that, I'm going to take a straight edge and try and connect my dots as best I can. That one looks pretty good. This one right here, on the other hand, does not appear to be proportional because it doesn't go through the origin. Now, this one's not perfect by any means, but it says which one appears. And I'm going to say that the calories graph appears to have proportionality because I'm going to say it. I'm going to whisper it. You know why? Because it's a straight line going through the origin. And we've said it like 1,000 times. I'm not going to write it for all you copiers out there, but it's a straight line and it goes through the origin. So you're welcome. Enjoy. Part C, for the proportional relationship. So that would be this one. Find the constant of proportionality. What does that number mean? Well, I'm going to use this ordered pair right here. I'm going to take 360, the calories, and I'm going to divide it by 24, which is representing ounces. Division, it's our friend when we're doing proportional relationships. So when I divide these two numbers, 360 divided by 24, it actually comes out pretty nice, and it gives me 15. So that represents 15 calories per ounce of coffee. That's what that means. What does that number mean? I kind of answered it right here. Find the constant. Okay, this is our constant, 15. And then what does that number mean? It means 15 calories per ounce of, and I'll let you guys fill in the blank there. What are we drinking? What are they drinking here? Calories of Kool-Aid? No, they're not drinking Kool-Aid. What are they drinking? They're drinking coffee. So write coffee in that blank there, and you got it.